Hello everyone and welcome again to this module on PN junction diode and its applications. In this video we are going to see a very simple thing, circuit symbol of the diode and its biasing. We will go through the diagrams for the circuit symbol of the PN junction diode, the forward biased PN junction diode, the reverse biased PN junction diode, and we are also going to see some typical packages and the LED identification of the diodes. Now, this figure shows you the circuit symbol of a PN junction diode. The arrowhead represents the P type, or it is also known as the anode, and the vertical bar, rectangular vertical bar, represents the N type semiconductor in the PN junction diode. It is also known as cathode. So, remember again, the P side of the diode is called anode, the N side of the diode is called cathode. One thing I forgot to tell you, the arrowhead indicates the conventional direction of the current flow when the diode is forward biased. Now, what is a forward biased PN junction diode? When a DC voltage is applied to a device, any device, the device is said to be biased. This diagram shows you a forward biased PN junction. In this diagram, you can see the positive terminal of the external DC voltage source is connected to the P region of the diode and the negative terminal is connected to the N region of the diode. In other words, we say that when the external bias is connected in such a way that the positive terminal is connected to P region, the negative terminal is connected to N region, and the external bias opposes the internal potential barrier, then the diode is said to be forward biased. But in simple terms, you can simply remember positive terminal connected to P, negative terminal connected to N, the diode is forward biased. Now, what is a reverse biased PN junction? This is a diagram for a reverse biased PN junction. The only difference you will see is that instead of connecting the positive terminal to P, we have connected it in the opposite way. The negative terminal is connected to P, positive terminal of the external bias is connected to N, then the diode is said to be reverse biased, or in more specific terms we can define it as when the external bias is applied in such a way that the negative terminal of the bias is connected to P region, the positive terminal is connected to N region, such that the external bias adds up to the internal potential V0, then the PN junction diode is said to be reverse biased. We are going to dwell more upon this forward biased and reverse biased PN junctions in the later videos. Now, coming to the other types of diodes, the first one which we will discuss is the light emitting diode. In short, it is known as LED. It is a type of PN junction diode specifically manufactured in which the input electrical energy is converted to output light energy. So, on the right you can see the diagram. This is the circuit symbol of an LED. What is the difference? You can see two arrows are shown going outward. These arrows indicate that the light is given out from the diode. This is the actual diagram of the LED. You can identify the lids of the diode, which one is the anode and which one is cathode, from the length of the lids. The longer one is anode and the shorter one is cathode. LEDs are also available in various shapes and various sizes and of various colors. So, you can see here LEDs of red color, even white color, yellow, blue, etc. Another type of diode is Zener diode. Observe the circuit diagram here, observe the circuit symbol here. In the circuit symbol of Zener diode, the only difference which it has from the PN junction diode is that instead of a vertical bar in the PN junction diode, you have here a Z type structure in Zener diode. So, in Zener diode, just remember that the vertical bar has to be shown with the Z sign here. So, it becomes a circuit symbol of the Zener diode. Zener diode is specifically designed PN junction diode, and the difference in the manufacturing is that both the regions P and N are very heavily doped. So, more impurity atoms are added in order to produce Zener diode. The circuit symbol is also shown here, and how does it match with the actual diode? You can see here the actual diode is shown here. So, you can see a black thing on the upper side of the actual diode. This black thing will help you identify the cathode and the anode leads respectively. Photodiode is another type of diode. Photodiode is a diode in which input light energy is converted to output electrical energy under specific conditions. So, here you can see the circuit symbol of a photodiode. In the circuit symbol you can see two arrows directed inward. So, keep this in mind, the circuit symbols are different for each type of PN junction diode. Here the lead identification is also shown. The longer one is anode, the shorter one is cathode, and some of the actual photographs of the photodiode are also shown. Laser diode is also one such type of specially designed PN junction diode, in which again direct conversion of electrical energy takes place to light energy. This is the circuit symbol of laser diode. Observe it very carefully, little different from LED, little different from PN junction diode. So, from the circuit symbol always we can identify, or we must identify, what type of diode it is shown. Two laser diodes are shown here, one with UV blue light output, this one, and another one is the handheld laser pointer. Laser pointers are very common in use during the presentations. Here the lead identification of the laser diode is also shown. You can see the blue and red leads, they tell you specific about the lead identification.